structuring and modeling an HR data model. In this lesson, we'll create an HR data model, we'll structure it, and we will prepare it for analysis. Let's get started. This is the Excel file that we're working with today. It is an adaptation of the IBM worksheet. Now what you see in this file is a name, a location ID. In addition to this data, we have geodata, and geodata is a collection of almost all the cities in the world. We have 7,068 cities. It's a 69 minus the header row, of course. In all the different countries in the world with a longitude and a latitude and an actual population. The population is not interesting, but the longitude and latitude is, and I'll show you later why. We have a calendar starting at 1950. We have a calendar for absenteeism starting in 2017. And we have the absence data, which is a long Excel file, which also starts on January 1st, 2017. And as you can see, it is ordered on an employee ID and a date. And what it does, it has all the employee IDs, well, not all of them, but the majority of the employee IDs in this organization, and it keeps track of all the different dates, and it either says no, someone is not absent, or someone is actually absent. And this is a massive file with over 500,000 rows. So this is a lot of information. It's over, if we do it 5 times 500,000, it's over 2.5 million individual cells. Together with the calendar, the two different calendars, the geodata and the HRM data, we have a lot of information. We'll import all this information to Power BI. And as you can see, I already created a number of tables and I named them appropriately, so importing to Power BI should be an easy breeze. I now go to Power BI and I can say either get data, or I go to the home screen and I click here on get data and I say Excel, import an Excel file. In this menu, I click, it's already open in the right map, the 6.3 HRM database. I open it, it connects, and what you see is the different worksheets in this Excel file and the different tables. And we're actually only interested in the tables. These are all the tables that we need, and I'll import all the tables. The tables, to give you a picture of what it looks like, the tables relate very much to what I showed you in the previous lessons. We have an absence, we have an absence calendar, and we have an HR system. And in addition, we have a calendar for the date of birth, starting in 1950. And we have the geodata for all the different locations. Because if we go to our HRM data, we actually have a city name for each employee, because they work at a certain location. And in order to map the different cities, we need a different filter on geodata, so on the cities. We have a lot of Miamis in here, we have a lot of people working in London, and a lot of people working in Quebec. So we have a filter table with just one location for Quebec, that acts as a filter. And we have a second filter table for the date of birth, which is actually the calendar that starts in 1950. But we'll talk more about it later. I selected all the different tables and I click load. And this loading process can take a few seconds. In fact, it can take a few minutes if you don't have a fast computer. It loads all the information, and I think the absence is around 15 MB. There we go. And everything is loaded. As you can see in the right top corner, you see the different fields with absence, calendar 2, the absence calendar, geodata, and HRM1. Let's right click this one and say, hey, we call this the HRM database. And the geodata is, and the calendar, we call it calendar since 1950 for the date of birth. That will just give us a better overview. And absence, those are the absence records. There we go. Now what we can do is we can open each one and we can get access to all the data in there. And to give you a preview, I can select, for example, the city name, drag it into the viewer, and I get an overview of all the cities. But that's something for later. Let's first edit the data, because if we start now playing around and visualizing the data, then we have totally skipped all the editing, and that will drive us into a lot of different problems. So instead of the report overview, we go to the data overview. And in the data overview, you can see the different data sets that we're working with. Now, we're gonna start off with the absence records. And the absence records actually look quite good. The only thing I don't like is the way the absence date is shown. So what I'll do, I click modeling, and in modeling I select the format, I select date and time, and I select the date, month and year, which is a European notation. I click it and we have a nice overview of what the data looks like. This dataset looks quite good. We have the absence true, we have the employee ID. However, our calendar table, our calendar dataset, doesn't look like we're used to. As you remember, when we created a calendar table, we had a date with a year notation, with a month notation, with a quarter notation, and with a day notation. We don't have that data yet. We just have a list of all the dates since 1950, and it's 24,000 something rows. Cells just filled with data all the way to 2017 something. What I'll do is I'll go to Home and I click Edit Queries. And now we enter the query editor. And the query editor, it's a new window, as you can see. The query editor enables us to edit all our data in a very systematic way. The absence records is the first query that's opened. Already looks quite good, and we already changed the date. However, the calendar doesn't look that good yet. The notation is good, but we don't have the year, we don't have the month, etc. Now what I'll do is I'll add a column, because we want the year, the month, etc. columns. And we say, hey, give us a date column. I want a month column. And as you can see, without any effort, a month column appears. I can also say, hey, give me, based on the original date column, give me a year column. That's a better thing to start with. I get a year column, I drag it to the left, because that just looks better. And now we also want let's create a quarter of the year column. And the quarter we drag to the left, so we have year, quarter, month, and the only thing we're missing now is a day. So I click date, I click day, and I say, hey, give me the actual day. As you can see, we also have a day of the week, a day of the year, a start day, etc. So I click the normal day, and now you see that we have the full date of birth table with a date, with a year, with a quarter, with a month, and a day. And as you can see, this process is way quicker than doing it in Excel. It's way more user-friendly if you know where to find the right buttons. Add column, date. Now, if I right-click year, I can change the type of date notation. It's weird to notice to write down the date as a decimal number. Let's ask for a whole number. And there we go, we see that the icon change and it goes to the whole number. Now if I click it here as well, we should be able to create a whole number, which is a quicker way to do it. For the month we want a whole number, and for the day we also want a whole number. And the date is already a short notation of the date with a day, a month and a year. Now this finalizes our calendar, our first date of birth calendar. We need to do the same thing for the absence calendar, because we have a list of a filter of all the days in 2017, and we actually want to add again the year. So we add the year. We want to add, and I click the date again, because that's the original source. We want to have a month. We want to have a quarter. And we want to have a day. And we do the same thing. We can either right click and say, hey, change the type, give us whole numbers. Or you can also click this icon and say, give us whole numbers for all the dates. There we go. So our calendar absence is also well defined and it works now. We can do the same for the HRM database, and we can look through everything. We have names, those are nominal values, they are letters, so to say. We have city names, we have age, date of birth, business travel. They're an ABC, so they're not categorical data at the moment. In order to change it to categorical data, we need to transform the data. That's not something we'll dive into in this video. But if you want to start to analyze your data, you need to transform, for example, travel non-travel, that's a 1, travel rarely is a 2, travel frequently is a 3, and then you have a scale from 1 to 3. And we have the geodata. And on the geodata we see the city names. And as you can see, some of the city names have, in Norway, they every now and again have weird or strange for most of us symbols for writing down the names. I hope I didn't anger any Norwegians. Those symbols are not always recognized in the standard way that Microsoft saves certain files. So as you can see, this something is wrong with this name. Same with the province name. So that's corrupted data, and you need to change that before you start to. It's really weird for Iceland actually. You need to change that before you start to edit the data. In our dataset, we mostly have US and Canadian companies, and I already manually did this for Quebec, which has a dash on the E, and that didn't register as a normal number, so I couldn't make the actual match. So I already edited the data beforehand in order to give you a good experience, because this is a dataset that I downloaded with all the city names and the latitude and the longitudes. I didn't generate this data myself, this is actual real-life data. So I already edited this data, but these kinds of things are signs that there are corruptions in your data and you need to clean your data. You need to go through it, and if you actually have someone or an office in this place in Denmark, you need to write down the actual name so it can actually match. On the latitude we see a decimal number, the longitude the same, population is a normal flat number, so that looks quite good. In other words, for now we should be good to go. What I do is I go to home and I click close and apply, and that saves all our data. You saw the saving screen, and we now have our calendar data, and our calendar for absence looks way better. If we now go to the geodata, we need to make give a number of commands. Namely, in modeling, we want to categorize the city, the country, the latitude and the longitude data, so Power BI understands that we're actually working with latitude and longitude coordinates. It doesn't know that by just looking at the data. It is actually quite smart in doing that, and it can actually recognize it every now and again. But you don't want to run the risk of discovering that it didn't actually recognize the latitude and the longitude when you're starting to create your visualization. So for city, I click data category and I go to city. It's actually a city. For country, we can select country. For our province and state, we can go to the state or province. There it is. Now the latitude and longitude, let's see, it already recognizes it. It's a number, so it can't be an address or a city or a country. No, it's a latitude, and on the longitude we say, hey, it's a longitude. And just to make it look better, we can create a decimal number that has 2 numbers behind the separation symbol. So we say decimal numbers with 2 behind the comma. Now our data looks, I think, quite good. I can walk through it once again. We have our calendar for absent, we have our geodata, and as you can see, the different variables that you see on the right side are now have a location symbol, so it recognizes the city as a city data category, the country, the latitude, the longitude. The population is actually just a whole number, and that's not in the data category, so it just remains a whole number. And we have the HRM database, which is much larger. I slightly changed this data set. The IBM dataset has attrition yes or no in it. We just assume that everyone in this dataset works in one company, and we're going to start to create visualizations because we want to have a lot of data basically. This is the overview of the data. And at this point we have edited most of the data, we have created the models, and what we can do now is go from the data view to the relationship view and actually explore the relationship builder. And in the relationship builder you'll get the actual answer to the challenge that I asked you in the previous video in the previous challenge. We already have one connection, which is, let's see if I click the connection, between the city name in the HRM database and the city from the geodata. So Power BI actually recognized that the HRM database has a lot of non-unique city names, while the geodata only has unique city names. And that's a good thing, so there's already a relationship. So I can put this to the side and let that relationship be. We have a calendar for the date of birth, and I created the date of birth calendar actually to go together with the HRM database, because in the HRM database we have and I need to find it, we have an age and we have a date of birth. So the date of birth of the HRM database contains probably quite some non-unique values. The calendar of birth has a long list starting from 1950, because the oldest person in the original data set is, I think, from 1952, has a long list of all the dates, so we can connect the date of birth from the calendar to the HRM database. And if I then hover on the relationship, it creates a directional relationship from this one to the filter table. So we have a calendar date of birth filter that goes on the HRM database. The date of birth in this case is transactional. It has a lot of non-unique values. And then we use, just like we did before, the HRM database. We use the employee ID to go together with the absence record. Now, it's a bit confusing, but the employee ID actually matches with the employee number. Power BI didn't recognize it because the variables are differently named. If we connect employee number with employee ID, we do get a connection which is directional again, because the absence records is the big transactional system. The employee number is now linked with the employee ID. We then have the calendar absence, and the date from calendar absence actually goes to absence date, and that's connected as well. And now we have our full conceptual model, and I can zoom out because it's starting to get quite big. This is the full conceptual model. You have the absence calendar connected to the absence records. We have the HRM database connected to the employee ID, the employee number with the employee ID. That's the model we had in the second lesson of this module, and we now added it, and that's the challenge that I gave you, the calendar for the date of birth to the date of birth of each employee, and we added the geodata to the location that people work in, not the location ID. We didn't match on ID, we just matched on city name, because geodata is a tremendously large database of a lot of cities and even very small towns with longitudes and latitudes, and we want to create a map for our organization. I hope you enjoyed the journey in making it. I would advise you try it yourself, copy all the actions that I did, experiment with the query editor. The query editor is quite interesting. If we start to edit queries, we get a whole new window, the query editor, where you can transform data, transpose it, split columns. You can basically do all the things that you can do in Excel, but it's going to be much faster. We can instantly create data on tables that are very large. As you saw with the table with 500,000 records, we could instantly create years, month, quarters, day notations for the smaller ones. This is just a tremendous fast way of working with tremendous large amounts of HR data and Excel data.